Hello, everybody. Here are your Chapter 9, Section 1 notes on point estimation. I also have your calculator handy because we're going to do some calculations. Now, in this chapter, we're talking about confidence intervals, but we first want to discuss in this section point estimation. What's a point estimate? A point estimate of a population characteristic, and by characteristic we mean maybe proportion or mean, but a point estimate is a single number that is based on sample data. And it represents a plausible value of the characteristic. So a point estimate would be, for example, our activity that we did yesterday is if I took a sample of the students in the classroom and I calculated their average height, and if that was a plausible value of the height of the whole population in our classroom, we would call that a point estimate. A statistic with mean value equal to the value of the population characteristic being estimated is said to be unbiased. So as long as the mean value of our statistic is the same as the population characteristic, it's unbiased. If it's not the same as the population, well, then it's biased. So think back to yesterday's example. If I take the 3 tallest people and I take the average of their heights, it's not going to be the same as the average of the whole classroom. Therefore, it would be a biased statistic. Whereas if I take a sample from our classroom and its average height is the same as the classroom's average height, then we would say it's an unbiased statistics. So we use our sample mean. So X bar could be used in an unbiased statistics for estimating the population mean, as long as the sample is 1, randomly selected, so that the sampling distribution of X bar is centered at U. And P hat could be used as an unbiased statistic for estimating our population proportion P, as long as the sample is randomly selected, so the sampling distribution of P hat is centered at P. So if our original population is this blue line over on the right here, we know that if we take a sampling distribution, it's going to be skinnier. So here in the green is our sampling distribution. And as long as their means are the same, whether it's a mean value or the mean of the proportions, we know that it could be considered an unbiased statistic. But if our sampling mean falls way over here on the side, so this would be an example of taking the 3 tallest people in the classroom and taking their average. Notice their average would be significantly more than the population average. That's biased. So that sample does not represent the population. The best statistic that could be used for estimating a population characteristic is always the one with the smallest standard deviation. So the smaller standard deviation you get, the better estimation it is for the true value of the population. All right, example 1. A sample of 200 students at a large university is selected to estimate the proportion of the students that wear contact lenses. So you want to know, what percentage of students wear contact lenses? You can't survey everybody at the university, so you surveyed a random 200 students. In your sample, you found 47 wore contact lenses. So based on the random sample, we're going to estimate what percent of all students at the university wear contact lenses. Well, we take 47 out of 200. So divide 47 on your calculator, divided by 200, and we get 0.235, or 23.5% of the population, we can assume, wear contact lenses. Here's another example, and in this example, we actually have our sample. A sample of weights of 34 male freshman students was obtained. So I have 34 data points. We want to estimate the true mean of all male freshman students. And I want you to find three things: the sample mean, what we call the trimmed mean, and the sample median. So first of all, let's do the sample mean. Take a couple minutes, pause this video, enter all these data points. It doesn't take long, really. It probably took me 40 seconds into your calculator, and then turn the video back on. So in my calculator, I have entered all the data.
Are you struggling to learn math? Try Question AI. Just snap a picture of the problem, and the app will provide you with an answer with step-by-step explanation.
Sorry about that. Gotta have that video. All right, so here's all my data. And so I want to calculate the standard deviation. I entered my data before the video, so you wouldn't have to wait for me. So there's my calculating. And I hit my list. And here is my data. So you're seeing two values. First of all, at the top, X bar 182.44. That's my sample mean. And down below, the standard deviation with the sigma, 25.39. That is the standard deviation for the sample. And so the standard deviation for the population would be the big S with the X, and that would be my population standard deviation. So let's go back. So my sample mean was 182.44. Now, trimmed mean. What is a trimmed mean? A trimmed mean is where you take off a certain amount of percent above and below your data. So if we want a 5% trim mean, we have to calculate 5% of 34 data points. So 0.05 times 34 is 1.7. We're going to round that to about 2. We're going to take off the top 2 and the top or the bottom 2 data points. So 231, 283, 139, and 148. So go back to your calculator. I'm going to go back to my list. And I'm going to take off, I believe it was 139. $283, 231, and 148. I'm looking for 231 and 148. Now I'm going to go ahead. I'm going to do my calculation. and I get my trimmed mean as 180.07. So my trimmed mean, 180.07. And then finally, my sample median. So let's go back to my calculator. Oh, and I should have wrote this down. Oh, it's probably still up here. Here we go. My sample median, 177.5. All right, when you want to find the estimate for the true mean, you want to use your sample mean. But there are other estimates. You can use the median, you can use a trimmed mean, but when you want to estimate the true mean for the population, use the sample mean. Okay, next up, let's go to estimating a population mean and standard deviation. If the population distribution is symmetric, there's 3 ways that you can estimate the middle. The sample mean, and I'll put X bar. Also the trimmed mean, and the median. All 3 can be used as an unbiased statistics for estimating the population mean. If the population is normal, if it's bell-shaped, the sample mean is the best estimation for the population mean. So just to remember, this is the sample mean, and mu is the population mean. All right, sample variance, S squared, is a good choice for estimating the population variance. And then the sample standard deviation can also be used to estimate the population standard deviation. So remember that S squared is variance, and the square root of that, which is just S, is your standard deviation. Now, there's a formula for this, so I'll go ahead and put it in. However, we're not going to be using the formula. You take the difference between a data point and the mean, you square it to get rid of the negatives, you add them all up, and you divide by n-1. So we use that formula to estimate standard deviation. We will not be doing it by hand in our class. Instead, we're going to let the calculator do that for us. So let's do that in example 3. The airborne times in minutes for United Airlines Flight 448 from Albuquerque to Denver on 10 randomly selected days are 57, 54, 55, 51, 56, 48, 52, 51, 59, and 59 minutes. So we want to estimate the population, and we're going to use that by looking at the sample mean for flight 448. So let's go ahead. So go to calculate. Oh, first I put my list in earlier, so I'll let you guys put your list in. Go to make a second list. So I put in all those times. And go to stat, go to calculate, go to one variable statistics. And there we go. There's my sample mean of 54.2. Now, how can we estimate the true variance in airborne time for flight 448? So we want to estimate the population standard deviation sorry, it says true variance. They were looking at sigma squared, but we're going to estimate the population deviation. And so we can do that either by the formula right here, or we can do that by calculating with our calculator. Now, if we did it by the formula, what we'd have to do is take each of the data points. We would have to take 57 minus the mean, square it, divided by how many are in our sample? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divided by 9. We'd have to add it to the next one, which is 54 minus 54.2, square it, divided by 9, and we would have to keep going until we did that for every single number. That's what the summation is, adding them all up, and then we'd have to take the square root. And it's entirely possible, but it's a lot of work, and that's only 10 numbers. What if your data set has something like 100 or 1,000 numbers? At that point, we want to use technology. For real data, people use programming like we're using. For small data like this, 10 data points, we can use our calculator. So we go ahead, we enter the data into our calculator, and we have our mean, and then we have our standard deviation. We are estimating the population standard deviation, so we use the big S and X. Sorry, I touched it and changed its color. So if you were just taking the standard deviation for the sample and assuming the sample was a whole population, you would take the 3.48. If you were taking all the samples and you wanted the sampling standard deviation, we've done that formula before. You would take the population standard deviation, 3.68, you divide it by the square root of the number in the sample, square root of 10. But in this case, what we're doing with this sample is we're trying to estimate the population standard deviation, and that's where you use the big SX, 3.8. So, whoops. The estimate of the population standard deviation is 3.68. So that's given the sample, what do we think the population standard deviation would be? And we estimate that it would be 3.68. And we can do it by using this formula, or we can let the calculator calculate it. All right, so that is a brief summary of point estimation. We're talking about means. We're talking about taking a sample. We know that the mean of the sample should be around the mean of the population if it's a good unbiased point estimate. And we now know how to use our calculator to take our sampling data and estimate the population's standard deviation. So we're going to estimate the population's standard deviation. And we did that using our calculator command. Now, please try the homework problems in the back of section 9.1. And I'll see everybody next class.